on the AutoHotkey forums, interesting problem came up. This guy works in some sort of sheet metal cutting factory estimate area, and they have some kind of machine here that takes a roll of sheet metal and runs it over these knives that make different strips of sheet metal for their customers. And he was, I guess this is a um, kind of a subset of the knapsack problem, which is a programming category for like how do you pack stuff into a limited, or how do you pack too many items, or from a wide selection of items, how do you pack all of those into a knapsack most efficiently? So he's got a special case, or a unique case of that. And I've been working on a solution here. Let me go ahead and show it to you. Right now, there's not much of a GUI. So what I have here, I'll run you through the code here. But how it kind of works is, um, it's not especially smart. It basically just tries a bunch of different things, and each attempt takes maybe 500 milliseconds, I would guess. And it keeps track of all of those, all the ones that satisfy the customer order. And one other thing that is relevant to him is how much waste. They don't want to waste any material. So right now I'm sorting mostly by the solution that makes the least amount of waste. Probably need to work on that a little bit more because um, there's might be some other constraints, like they don't want to over deliver for the customer if they don't have to, or they would like to deliver enough to satisfy the customer with the least amount of sheet metal cut. So that could be another sorting thing that I'll work on here soon. But okay, so what happened was it went through all that, and I have it set to only remember about 100 of the working solutions. So it tapped out at 100 for this problem. Other problems, I don't know, are physically possible. It can go for 20 minutes and not find a solution. So I'm waiting to hear from him on some more real orders, because he only really gave me one or two. Okay, and then it just kind of outputs all this. This might be a little bit hard to read. Um, but right here we have the knife, the blade arrangement. So how far apart they should be spaced. And this is the inventory that should be used. So they have a very simple inventory system that keeps track of the weight, and it has a little tag on it. So it looks like here we use two rolls. One roll weighed 3,300 pounds, another weighed 3,590 pounds. And then the customer order was just defined here in memory. Uh, Here's a few orders that I've been working on. This one was kind of the simplest one that I could find a lot of solutions for, whereas this one is a little more troublesome. And okay, so how it works is I'll just jump straight into the function. Those are just some timers to kind of help you see that the app is still running. How it works here is it takes an inventory object, takes an order that we saw previously, and I think this max rolls is like how many. We don't want to use too many rolls of sheet metal, so this is kind of like a artificial limit for the user can set. Well, this order normally would take me 2 rolls, so I can't have a solution that uses more than that. Um, Okay, and so it goes into a while loop, and the while loop basically just, I have a global settings object, and it has a max attempts just to, keep the app from running all day, all night. And from there, it'll try an attempt. So what we do is we take a sample of the inventory. So just um, this will select from 1 to 4 to 5 rolls of of that inventory, and it'll put in an object called set. And then the cuts, what's going on here is for all the cuts, we just want the width values. In the cut in the order is also how much needs to be matched. And then this goes in and makes a blade arrangement. Now this function will try to use up as much of that roll as possible. There is a slight oh, okay, so that tells it the width of the roll that we're working with. There's definitely room for improvement on this. Right now it won't mix and match different widths of inventory. It assumes that every piece of inventory you put in is all the same size. At least right here. And then, okay, this is a kind of an important function. What this does is it checks how much of that roll was cut, and it returns quite a large object that holds. We can jump down to that actually. So this definitely could be some cleanup here, but I wanted to keep track of exactly what the order is going to make, and as well kind of an overall view of what the order will generate. So the order not only generates the exact, I think what I forget what they call them. But I call them outputs. So the little tiny, not scraps, but cuts of a roll. I can't remember the word right now. Anyways, and it also keeps track of some totals, like, so this is all the little tiny cuts, and then the totals is kind of an overall, like, how much of the roll got used, because on the edge of the roll, here, let me show this picture again. On the edge of that cut, the machine is not perfect. It always needs a little bit on the edge that can't be perfectly cut with the blades. I don't know if there's like a mechanism that grabs onto the sheet metal and destroys that end, but it always has to be cut off. And so it always needs at least a ½ inch for the machine to work with. And so let's just call it this piece right here. That piece is considered the scrap. So basically how this works is for every roll in the inventory, let's try the cut on it. And this would be our blade arrangement. And it will put all of those cuts into that an array here. So when we get that answer, we will get all of these outputs, which is each individual little strip. I believe. I mean, these are quite heavy. I mean, look at that. Okay. But these are about small, about what I normally see. So I think what happened is we had a really thick roll. It was, yes. I'm recording a video right now, so make it fast. Did you eat your food? Okay. Okay, so kids need me. I better wrap this up. Let's see here. Oh, okay. So let's jump back up. Okay, so the result, we get this huge result. Now I needed to understand that whole result as a small number. So what this does is this turns that out, or we make a clone of that result object. And then for the outputs, I just overwrite it as combined similar widths, because we got all of these little pieces for the customer, and I just need to know how many of those, how much all of those weigh, but also how much. Here, let me show you the order. So the customer wanted this thickness, and it has to weigh this much or more. So that function just combines all the little strips of this thickness to get a big number instead of a bunch of small little numbers. Okay, so that's combined similar widths. And then this, just for our GUI thing, tells me how many, well, so let me tell you about this in a moment. Next, we check if it meets all the order requirements. This is a function. It just understands if the order is satisfied by this combined result, and it returns true or false. And then we also want to know, did that scrap, that total scrap, that end piece, is that under the max allowable? Now, listening to that guy talk, he seemed to like it when the scrap percentage could be under 5%. So that's what this is trying to accomplish. And I used to just remember those, but at the moment I'm memorizing more of them. Now, so what happens is we have this object, or we have this array, and we just push on that inventory, or let's see, we push on the inventory, we push on the blade arrangement, we push on the combined result, so you know what happened, and then just as a quick sanity check, we have that scrap yield. This sums up all the scrap pieces because there might be multiple rolls, and each roll might have a different scrap percentage. But also, you know, if you run 3 rolls instead of 2, you can definitely have more scrap. So this will put together all of those. And then just to keep Windows happy, I thought, well, we don't want to add too many thousands of items on here, so I kind of just have some logic here for, let's just keep the attempts, you know, to a sane level. The user can specify 0, and all of them will be remembered. Okay, so then at the very end of the loop, it will exit out of there after, you know, enough tries. And if we don't have any satisfying things, we'll get just a message, no solutions found. Else, we'll get solutions found, tell us how many. We'll go ahead and sort them by the scrap yield. Probably what I could do is something like, we'll have to write a function to figure out if it went over the order too much or not. And the other thing was, we want to know, well, I'll figure this out later, but we want to know, let's also sort by the number of rolls that were used. So I think that's here. Let's look at our output here. That would be, I might have to arrange this object a little better to get that, but what would that be? That would be inventory. Oh, okay, so that would be I think inventory dot inventory.count. I don't know if I could do that immediately just like that. I don't think I can. So we might need to just save a number on some other thing like used roles. And that would be set.count. Oh my goodness, that's not good. And now we would be able to go like that. So let's give that a shot real quick. Sorry, I got an error here. What's it mad about? Oh, it's mad. I probably need to go like this. So let's give that a shot and see how it goes. And then there's just a little cleanup, turn the timer off. There's a timer that kind of has this do its thing. Now, did I set this? So this number right here is not labeled real clearly, but this is the number of attempts. I think I set it to 1,000. Okay. So now, okay, so we used 2 rolls, and I wonder, let me drop that number down just so we don't have to wait a long time. Let's try 400 attempts. And what I want to do is, just to prove to myself that this is working, let's take also the worst performing. Let's take the worst performing one and see that as well. Okay, we should be here. Now this one, this one used 4 rolls. And then our better one was probably up here. They're so close to each other, it's a little hard to see. Oh, there it is. We used 2. So that's kind of cool. I'll go ahead and we'll throw that out. We got our proof. And I think that's pretty much the app. Let me see. I was working on a GUI for it. Let me see here. It's a Neutron GUI, and I'll try to get this working, but we were just going to print those out so it's a little bit easier to read. And some of the stuff is wrong. I misunderstood what he was trying to accomplish. But that's my app. I did want to say that, you know, I used the Big A library, and it was just invaluable, as usual. There's a few more libraries here, but I actually didn't use that one at all. Oh, I guess that's the only one. It just makes my life a whole lot easier. I know you could probably do things in a harder way and get similar results, but this is what worked for me. And anyways, I hope it was interesting for you. I did put this on GitHub, so you can follow it there. Let me see if I have it open here at all. I don't think I do. Oh, actually, you know what? I linked it in the thread, so let me click on that. It's called PPA SheetMetalKnappApp, and if you're interested in helping with the GUI or helping with the features, there's definitely room for improvement. Go ahead and send me a pull request or make the changes and then send it. One thing I think could be definitely improved is try some different knife arrangements. Right now, it makes one knife arrangement and tries that on all the rolls. We could definitely open up the possibilities to more efficient orders with that kind of change. The other big thing is I need a function to see how much different the customer order is from the output, because right now we might be over delivering to the customer. He says that's normal, that's fine, and that's done. But if we could write a function to measure that, then we can sort by the solution that does that the least. So that would be helpful. All right, I think I'll end it there. Thanks for checking it out.